Hey guys, welcome to part 8 of my video series on creating a serverless REST API using AWS and the Python programming language. So in the last video, we got a basic introduction to DynamoDB. We learned how to interact with DynamoDB using Python programming language. And what we're going to do in this particular video is that we're going to complete our API, our student API. We are basically going to use DynamoDB to save the student data, and we're also going to make the various routes which are required for creating our student API. So without any delay, let's get started. Okay, so here is my PyCharm project, and I have done a few simple changes in my CloudFormation template, or you can say the SAM template specification that we're using here, right? So this is a SAM template basically. So a few changes which I have done here are, first is I have added the CloudFormation template code for creating a DynamoDB table. So I'm calling my table students again, and I have given the type as AWS DynamoDB table. And then what you have to do is you have to provide the attribute definitions, which is all the attributes which are going to be used as keys somewhere in your table. You have to define the type of all those attributes. So I've defined ID as my attribute and its type is a string. And then the key schema refers to what all keys you are using for what all purposes. So we are just using a simple partition key, which is a single key being used as a primary key. So you call it hash key. So attribute name is ID, which is this one. And then you are calling the key type as hash. And then you have to provide the provisioned throughput, which is read capacity units and the write capacity units. And if you increase the value of these, your DynamoDB table will be more fast in terms of querying. Okay, so these are a few things that we need to know, but more importantly, how do you find what are the various attributes that you need to provide here in your table, right? So always what you can do is that you can search for CloudFormation, let's say DynamoDB. Let's say you want to know about how to write that CloudFormation for DynamoDB tables. So just search for CloudFormation DynamoDB, and then you will get a doc which looks a bit like this. Yeah, so here you have the JSON format and the YAML format for writing the CloudFormation template. So this is the YAML format. So you have to specify the type, and then you have to specify the properties, where let's say you have the table name, right? And then you have the attribute definition. So let's say you do not know about what is attribute definition. So just click on attribute definitions and you will get to know about it. And you see that it is a list of attribute definition. So just click on attribute definition and you will know what all attribute definition contains. It contains an attribute name and a type. Now you do not know what to provide in a type, so just click on type, and then you have the options of string, number, or binary, and so on. So this is as simple as that. The docs are very clear, and you can always refer to them whenever you feel the need of trying to understand how to write your CloudFormation template. So yeah, so this is how I have written my very simple students table. It will contain all the data for my students API. Then I have to allow my Lambda function to access this table, and for this SAM provides you a very simple solution, which is to use the policies property, in which you have to use the DynamoDB CRUD policy, which is an already created policy which provides you the permissions to create, retrieve, update, or delete any item in your DynamoDB table. So here I have to just specify for which table I want to do this. So I just provide the reference to my table, student table. So this student table is actually the name of the CloudFormation resource that I have created here, student table. So that's why it will match, and it will tell it that this is the table name on which I want this policy. Now you might be thinking that how do you know what it does or how to explore this, right? So again, you have to search AWS serverless function IAM role, or let us just go with AWS serverless function first. Okay, so in the AWS serverless function definition, you will get the syntax, and in the syntax we have something called policies. So now in the policies, you can check these various SAM policy templates that we have. Okay, so in the SAM policy templates, here you go. You have the policy template with placeholder values. These are the policy templates which have already been created for your use. So these are all the policy templates that you have. You have SQS polar policy, Lambda invoke policy. So here you have DynamoDB read policy. So if you use DynamoDB read policy, you are giving the permission to Lambda function to only read from a given DynamoDB table. But we want to make a CRUD API, which is create, retrieve, update, delete. So we are gonna go with DynamoDB CRUD policy. Now you might want to know what it does. So you can just click on it and you see it will allow you to get item, delete item, put item, and so on a particular DynamoDB table. And I have to provide the table name. So this is where it says that I need to provide the table name, right? So yeah, so it is as simple as that. And in this way we have given a policy to our Lambda function to access our DynamoDB table. And now finally, in order to create the various routes for our API, what I've done is in the event section, I've created some multiple events. So here is an event which is called list students, in which I'm saying that the path must be /students and the method should be get. So what will happen is that a new route will be added to my API, which is /students, in which on having get request, this event will get triggered and hence my Lambda function will run. So I needed multiple operations on my student API. So one of them is listing the students. Then another one is to create a new student. So that is again /students. The path is /students, but the type of request should be post. Then we have the get student, in which you will provide a placeholder value as well, which is ID. So we will get that. And in this way, we'll be able to get a particular student by ID. Then we have path student, in which we will update the student by the given ID. And then we will delete a student for given ID. So in this way, I have added multiple paths. So we already had a default event that we created in the last video, which is on simple / we are doing something. So let us see in our app.py. In our app.py on / we are just returning message hello world. This is as simple as that. So yeah, so this template is what I created, and I will be providing all the relevant links of various docs from which you can read about those resources, CloudFormation resources, like how to create them. So all of them will be provided in the README of the GitHub repository of this complete project, and the link to that GitHub repository will be provided in the description of this video below. Okay, so now let us move on with the coding stuff. So the first thing that I'm going to do is I'm going to install Boto 3. So as we know, Boto 3 is the AWS SDK for Python. So pip install Boto 3. Okay, so this will install Boto 3 in your virtual environment. So we are running our project, we are creating and doing everything in a virtual environment, right? So we need to install Boto 3 in our virtual environment as well. This is the first thing. Then we need to put Boto 3 in our requirements.txt so that SAM build knows that it has to put all the code of Boto 3 to in the package that it creates for the Lambda function. Basically, we need to upload the code of Boto 3 as well to our Lambda function. So that is done. And now let's go to the app.py. So what we're gonna do here is that we are gonna write the code to process some more routes. So /students, and let's say the methods is get and post. So we are allowing get and post method on this particular route /students. So def put, so let me call this function as put or list students. Okay, and now what do we need to do? First of all, we need to know whether the type of request is get or post. So to get the context of the request, we have to use the request object provided by Flask. So from Flask import request. So once that is done, now what we can do is if request dot method is, let's say, get. So what do we need to do? We need to scan the complete DynamoDB table and return it, right? So now how to scan the table? So we need to use Boto 3 here. So I'm just gonna do import Boto 3, and then we will create a DynamoDB resource from our Boto 3, Boto 3 dot resource DynamoDB. Okay, save DynamoDB name so that it doesn't show me error every time. Okay, it's fine. So DDB is boto3.resource DynamoDB, and now the table instance table is equal to DDB dot table, in which I have to provide my table name, which is called students. As simple as that. Okay, so once this all is done, now we can go ahead and we can try to scan the table, right? So what I'm going to do here is that I'm just going to return what I get, right? So students is equal to table dot scan, and as you might remember that what we were doing here in our last video was that when we do table dot scan, we get key called items, in which we have the list of items. So we just want to return items only, right? So I'm just gonna put the items key here, table dot scan items, and we get the students list. So now what we need to do is just return it. So return, and now again following the same logic, json dot dumps students. This is my message, my response body. The response code is 200, and again the content type is application slash JSON. This is how the client should understand it, the person who called me, right? Okay, so this is done. And if this is not the case, which is the request type is, let's say, post, so what are we going to do in that case? So in that case, we have to write the provided request body as the student item, right? So for that, we have to do table dot put item. So in table dot put item, we have to provide the item. So right now what I'm doing is, in the item, we are just going to do item is equal to the request dot form actually contains all the request body that you get in a post request or any kind of request. But the thing is that this request dot form is an immutable dictionary, which is the dictionary which cannot be changed, right? But we want to make it mutable. So for that, we use toDict function of an immutable dict, and that's it. So this should do the job for us. And finally, we can do return, and in the return, just do json dot dumps. Let's say json dot dumps, and let us call it message student entry created. As simple as that. And we can again return the response code as 200, not a big deal. And the content type is again application slash JSON, because we are returning the data in that format only. Okay, so it is as simple as that. And now I think we should test whether our code is working fine or not, right? So let us go back to our terminal, and let us do sam build and sam deploy. Let us do both the things consecutively by a single command. Okay, so our change set of our CloudFormation stack got deployed, and now let us open the AWS console. So here, let me go to the API gateway, and in the API gateway, let us try to see. Okay, one more thing that I'm gonna do is I'm gonna open DynamoDB. So in DynamoDB, if we try to look at the tables, we will see that the table called students got created, right? So yeah, so we have got our table called students created, and in the items, there is nothing as of now. Okay, now in the API, let us go to the student API, and in the student API, let us see what all paths have we got. So look at that, we got all the paths that we specified in our CloudFormation template. Through the events, we specified that there will be students with get and post option, then there will be /student/id with delete, get and patch option. So that is fine. Okay, now let us move to the stages section. So in the stages, we must already have a prod stage. We can see that, right? And the prod stage has this particular invoke URL, but let me go into the /students/get. So for that, this is the invoke URL. So let me just open it in my browser. So whenever you enter any URL in your browser directly, what you are making is a simple get request. So look at that, I made a simple get request, and what I got in response is an empty list, because there is nothing in my DynamoDB table as of now, right? So now the next thing that I'm going to do is I'm going to click on this, the post stud/student. So this is the same invoke URL. So I'm just gonna copy it, and now what we're gonna do is we're gonna make a post request. So in order to make a post request to our API URL, I'm gonna use the request library to do that. So we are gonna make the request programmatically basically. So import requests, the URL is equal to the base URL, let us call it, and in the base URL we have this. Let me remove this space. Okay, so in the base URL it is up to prod only, and then let us do requests dot post, and it will be base URL slash students. So this is my final URL for calling the create student API with a post request. And in the body, in the data part, I can provide whatever I want to create, right? So the ID, I want it to be 1, and the name I want to be Nikhil, and let's say branch I want it to be, let's say COE. Okay, so this is as simple as that. We have created our request as well, so let me just run it. So our request is being sent, and once that is done, we can do r dot content. So look at that, r dot content is saying that message student entry created, which means that everything went fine. So let me just reload here. So look at that, we are getting that ID is 1, branch is COE, and the name is Nikhil, which is perfectly fine. So if I just try to run my get query again, I should get the student data, right? So yeah, so we're getting this as well. So it means that we have correctly written the code for 2 of our student API queries, which is to get the list of students and to create a new student entry, as we saw here, right? So now let us finish the other remaining APIs. So it is going to be @app.route, in which we will take students slash, we will be having an ID, right? So ID, and the methods are gonna be get and post. Okay, so I'm a bit unsure about this particular format, so let me just search a bit. Flask URL path params. I guess I've written it right, but let us just test it. Okay, so yeah, I think it is fine. So if you write something here, you have to take it as an input at this particular position, right? So I think it is fine. So /ID is fine, and then def student. So we are gonna do multiple things, right? Get patch. So you can think of better names for giving for this particular function that we are creating here, but let us just go with this name, and we have to take input as ID, right? So this seems good. And now what we have to do is, if request dot method is get, so what do we do in that case? We get the student data. Student is equal to table dot get item, in which we have to provide the key. So key is ID, whose value is ID, as simple as that. And then we will return something, right? We will do return json.dumps student, and 200 is the response code, and the content type is application/JSON. So one thing that you can do as an improvement to this code is to remove the requirement of putting this content type application JSON every time. So that is as a small activity for you. If the request pattern is this, elif request dot method is, let's say, patch. Okay, so I wrote it wrong here. We have to do get patch delete. So if the request method is patch, what are we gonna do? We are gonna do table dot update item, with key is again gonna be ID is going to be again ID, but now there can be multiple fields, right? So what are my attribute updates going to be? So attribute update, so we know that we are not gonna delete any attribute, and also we are not going to add something to any existing attribute. We are just gonna put, right? So attribute updates is going to be so what we are expecting from the user is a dictionary in which they will provide the name of the attribute and the value of that attribute, right? So the attribute updates looks a bit like as we did it in the last video. It looks a bit like this. You have to provide the name and then the value and the action, right? So we have to just create a dictionary like this. So how do we do that? So I have to just use dictionary comprehension here. So I am using did comprehension, in which I am just gonna do it like this. Key, then the value will be value, and the action will be put for key comma value in request. So again, where will I get this data? It will be in the request body. So it is request.form.items, as simple as that. Okay, so this is what we have done in order to create our attribute updates. So let me just pass these attribute updates like this, right? So yeah, so in this way our table, this particular item will get updated. So it looks fine, and I think it's cool. So there are some kind of validations which you might want to add to this API, but again, I would like to left it as an exercise. For example, if a student entry already exists, then you would not like to put it again, right? So these kind of validations you can do. Similarly, if user is providing some wrong values here in this request body in the request.form, then you can again check that. So these kind of validations are left as an exercise for you, because there is nothing difficult, I think, with them, but you should just try to do that yourself. So in json.dump message student entry updated. Okay, so this is also done. Let me just provide it as 200, and the content type is again application/json. And now let us move to the final thing, which is if the request type is delete. So it is quite simple. Table.delete item, in which we provide the key is equal to ID. That's it, and then just return saying that student entry deleted. Okay, so yeah, so finally all the code is ready. We have written it. So we are doing table.get item, table.update item, and so on. So let us try everything out here now. So what I'm gonna do is just again SAM build and SAM deploy. Okay, so the deployment is complete. So let us test it now. So the first thing that I would like to test is the get request. So in my DynamoDB table, there is already an ID1. So let me just put /students/1, and let us see. Okay, so we are getting the item, but one small mistake that we did here was that we needed to just provide the item details, not all the other details. So that can be simply fixed by just putting student is equal to table.get item and then using the item key only, right? So this is a small mistake that we did here, so that is fine. And other than that, what else do we need to check? We need to check the patch and delete, right? So let us first test patch. So in order to test patch, let me just go back to my Jupyter notebook, and here r is equal to requests dot patch, in which the URL will be base underscore URL, again slash we will provide /students/1. So this is my URL, and then we have to provide some data. So data is equal to, I just want to update the name to Nick only. So let me just run it. It ran. So r dot content message entry updated. So let us try to update, let us try to reload this page. So look at that, the name got updated. We are getting it as Nick now, right? So it means that our update operation or the patch operation is working perfectly fine. And finally, just to wrap up this video, let me just test the delete request. So let me just copy this all and replace patch with delete and remove this data thing. So now it should delete my item. So r dot content message student entry deleted, which means that if I just try to do if I just try to see the list of my students, I should get an empty list because there is no student remaining, right? So yeah, one small thing that you can fix in this particular code is that if no entry is available, or you get no entry while you try to do a get item, you should handle that case and should return 404 not found and so on. So that is also left as an exercise for the viewers. Okay, and yeah, so this is how we have finally created our student API, which seems to be perfectly fine. It seems to be working perfectly fine, and it is supporting 5 different kind of operations on our DynamoDB table. And I hope you enjoyed it, and I hope you will be using now Flask along with AWS Lambda and DynamoDB in your next serverless REST API application. Now, if you still have in doubt, you can put them in the comment section below, and all the resources related to this particular series will be available in the readme of the GitHub repository, whose link will be provided in the description of this video below. So check that. So don't forget to check that out, right? So yeah, so that's all from this video. Thanks for watching.